Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Afiq Aiman bin Jasmadi, and inshallah, today my team and I would like to present about differentiation of sum and product rules. So, here we go. So, for this chapter, this is my team members, and the first one is me, Afiq Aiman, and second one is Nurin Zulaika, Nur Farahin, Khadijah Hana, and Ain Shazwan. Okay, so we proceed. So here we are, sum and product rules. So before we go more further about this chapter, we must know what is the use or application in this world about sum and product rules. So we see here that this chapter is commonly used in a mathematical induction. Next is application in physics and chemistry. For chemistry, differentiation is commonly used to calculate the rate of reaction, and the engineering is commonly used to determine the minimum and maximum particular fraction.
Okay, in this topic, I will explain to you what is sum or sum rule. We know how to take the derivative of single expression, but what happens when there are two expressions, three expressions, or even more? How do we take the derivative? Of course, we use the sum rule. Take each individual expression derivative, then take its sum. It is very simple. This rule also applies for limit. If we have to evaluate a limit consisting of several terms, we can evaluate each individual term's limit and then sum it. In calculus, the sum rule is actually a set of three rules. First, it is a limit. Second, derivatives. And third, it is a integration. We use the sum rule when we have a function that is a sum of other smaller functions. At this point, we will look at sum rule of derivative. What is the sum rule of derivative? The sum rule of derivatives tells us that the derivative of a sum is the sum of the derivatives. Now, we will look into the sum rule of derivatives. The derivative of a sum is equal to the sum of the derivative. To take the derivative of a sum, you break apart the sum into single expression, take derivative and add them. So we have a sum of fx plus gx. To take its derivative, we have the derivative of fx and gx individually and then take the sum. For the example, d over dx in bracket fx plus gx equal to d over dx in bracket fx plus d over dx gx, and we can get f prime x plus g prime x. Not f prime x is the notation for the derivative of the function fx. Okay, next, it is important to how do we know to differentiate a sum. If we have multiple terms in the form of a sum, for example, y equal to x power of 3 plus 8x plus 1, then in order to find dy over dx, we apply the differential operator on each of the terms in turn. So in the other words, we differentiate each part of the sum one by one. Consider that y equal to x power of 3 plus 8x plus 1. If we want to find dy over dx, then we will apply the operator d over dx to both sides of the equation, giving us. First, we must apply the d over dx operator to each term. For example, dy over dx equal to d over dx in bracket x power of 3 plus 8x plus 1. Next, we must differentiate each of the terms individually. dy over dx equal to d over dx power in bracket x power of 3 plus d over dx in bracket xx plus d over dx on 1. So we can simplify dy over dx equal to 3x power of 2 plus 8x plus 0. So we can get dy over dx equal to 3x power of 2 plus 8x.
Next, we move to examples for differentiating a sum. Okay, next we move to example 1. The equation is y equals to e to the power of x plus 4x to the power of 6. Okay, we need to differentiate each part of the sum one by one. So we start with this part first. Okay, we use this formula y equals to e to the power of x. The derivative is equal to e to the power of x. Okay, next we move to the second part, which is 4x to the power of 6. And we use this formula. We need to bring down 6 to the front and then times with 4, and we need to subtract 6 with 1, so we will get 5, and then we will get dy dx equals to e to the power of x plus 24x to the power of 5. Okay, next we move to example 2. The equation is y equals to ln 2x plus 1 over 3 sine 9x. Okay, as before, we need to differentiate each part of the sum one by one. So we start with this part first, ln 2x. So to differentiate it, we use this formula, y equals to ln x. The derivative we will get 1 over x. Okay, and for the second part is 1 over 3 sine 9x. Okay, we need to use this formula, y equals to a sine bx. A is equal to 1 over 3 and b is equal to 9. Okay, and then the derivative, we use this formula. Okay, so we can insert the value a equals to 1 over 3, b is 9 cos 9x, and we will get the dy dx equals to 1 over x plus 3 cos 9x. Okay, next we move to example 3. The equation is differentiate z equals to cos 4t plus 6e to the power of t plus t to the power of 5 plus 2t to the power of 2 plus 7 below with respect to t. So basically we need to find the z dt. So we need to differentiate each part of the sum one by one. So we start with cos 4t. Okay, we use this formula, which is y equals to a cos bx. A is equals to 1, b is equal to 4, and the derivative we will use this formula, which is negative ab sin bx. So we will get the derivative equals to negative 4 sin 4t. Okay, we move to the next part, which is 6e to the power of t. Okay, we will use this formula, which is y equals to ae to the power of bx. A equals to 6, b equals to 1, and x equals to t. And the derivative we will get ab e to the power of bx. So we will get the derivative is equal to 6e to the power of t. And then, okay, we move to the next part, which is t to the power of 5. And we will use this formula. We need to bring 5 to the front and then subtract 5 with 1, we will get 4. So we will get 5t to the power of 4. And next, for 2t to the power of 2, we need to bring 2 to the front. So we will get 2 times 2, we will get 4. And then 2 we need to subtract with 1, so we will get 1. So we get t to the power of 1. And for 7 we cannot differentiate it, so we will get the dz dt equals to negative 4 sin 4t plus 6e to the power of t plus 5t to the power of 4 plus 4t. Okay, next we move to example 4. The Osenze equation describes the relationship between the conductivity of a simple ionic salt in solution and the concentration where the limiting conductivity and B are constants. Find the conductivity over DC. Okay, so we will differentiate this equation, and we need to differentiate each part of the equation one by one. So we will write at this d by dc of limiting conductivity minus with b d by dc of c to the power of 1 over 2. B, we put b at the left because it is a constant. Okay, then we can differentiate it. The derivative of limiting conductivity will get 0 because it is a constant, and we can differentiate c to the power of 1 over 2 using this formula. So we need to bring 1 over 2 to the front and subtract 1 over 2 with 1. So we will get 1 over 2 c to the power of negative 1 over 2. And then we calculate, we will get d conductivity over dc is equals to negative b over 2 c to the power of negative 1 over 2.
Next, I will introduce about the product rule. So, what is the product rule? Okay, in calculus, the product rule is a formula used to find the derivatives of products of two or more functions. Okay, let's look to the example and how to solve it. Okay, suppose we want to differentiate y equal x to the power of 2 sine x. Then we encounter the problem how to differentiate a function that is the product of two other functions. In this case, we have two functions. Okay, so the first function is x to the power of 2, and the second one is sine x. So before we start to solve it, let's look to the formula first. So here the formula. As you can see, d uv per dx equal to u dv per dx plus v du per dx. So, for duv per dx, it is the derivative of uv with respect to x. And u is variable of u, and dv per dx is derivative of v with respect to x, and v is variable of v, and du per dx is derivative of u with respect to x, and du is variable of du. Returning to our example, we have fx equal to x to the power of 2 and sine x, with the u is x to the power of 2 and the v is equal to sine x. Okay, first, after that, we need to find for du per dx and dv per dx. So for du per dx, as you can see, it is equal to 2x, and for dv per dx is cos x. We change sine x to cos x. Then we can substitute into our formula. So it will be dy per dx equal to x to the power of 2 cos x plus sine x 2x, and we differentiate it, and it will be dy per dx equal to x multiplied by x cos x plus 2 sine x. Okay, that's all from me. Let's look to the next slide for more example of product rule.
Now let's take a look for some example of product rule. For the first question, we get y equal to x squared multiplied with cos x. So when we know the is multiplied, so we should use the product rule because product rule is applied when the two parts of the function is being multiplied together. Okay, first thing first, we should determine the u and the v, which is usually u is the first part of the function, while the v is the second part of the function. So we get u equals to x squared, while the u prime of derivative of u is 2x, while the v equal to cos x, while the derivative of v is negative sine x. We have determined all the value of the u prime, v and v prime. So we should insert into our formula, which is dy over dx equal to u multiple with v prime plus v multiple with u prime. So we have our u is x squared, our v prime is negative x plus v is cos x, while the u prime is 2x. So we expand all the value and we get the answer is negative x squared sine x plus 2x cos x. We move to our question number 2, which is the function is y equal to 4x squared multiple with in bracket 3 plus x to power of 5. Now we determine the u and v, which is the u is 4x squared while the v is in bracket 3 plus x to power of 5. Then we determine the u prime and the v prime, which is the derivative of u and v, which is we get u prime is xx while the v prime is 5 in bracket 3 plus x to power of 4. Now we have all of the value. Then we insert into our formula, which is dy over dx equal to u multiple with v prime plus v multiple with u prime. So u we have 4x squared while v prime we have 5 in bracket 3 plus x to power of 4 plus v is the in bracket 3 plus x to power of 5 while the u prime we have the xx. So we expand the bracket and we get 20x squared in bracket 3 plus x to power of 4 plus xx multiple with in bracket 3 plus x to power of 5. Our third equation, which is ft equal to in bracket 4t squared minus t multiple with t cubed minus 8t squared plus 12. Now, as usual, for the product rule, we should determine the u and v. So our u is 4t squared minus t, while our v is t cubed minus 8t squared plus 12. Then we should find the derivative of u and v, or the u prime and the v prime, and we get 8t minus 1, and for the v prime, we get in bracket 3t squared minus 16t. After we get all of the value, and we insert into our formula, which is dy over dx, u multiple with v prime plus v multiple with u prime. So our u is 4t squared minus t multiple with our v prime, which is 3t squared minus 16t plus with our v is t cubed minus 8t plus 12 multiple with our u prime, which is 8t minus 1. Then we expand all of the unknown, which is the 4t squared with 3t squared, and we get 12 to the power t to the power of 4, and then the 4t squared with the 16t, and we get negative 64t cubed, and then the negative t to multiple with 3t squared, and we get negative 3t cubed, and the last one negative t multiple with negative 60t, and we get plus 16t squared for the first function. And the second multiple with the second function, and we expand it also. So t cubed with the 8t and so on. Then we get 8t cubed minus t cubed minus 64t cubed plus 8t squared plus 96t negative and minus 12. Then we solve the problem and we get 20t cubed minus 132 t cubed plus 24t cubed plus 96t minus 12. And remember, we should leave in our answer in the simplest form. Now, don't leave our answer in the second part because it will leave our work is undone. Okay. For the last question, question 4, we get the function which is fx equal to x squared multiplied with ln x. So we know with the first step in our product rule which is determine the u and v. So our u is x squared while the v is ln x. So we know in the formula we have the u prime and the v prime. So our u prime which is a 2x while our v prime which is 1 over x. So we insert all of the value into our formula. And what is the formula is dy over dx equal to u multiplied with v prime plus v multiplied with u prime. So our u is x squared multiplied with v prime which is 1 over x plus our v which is ln x multiplied with u prime which is 2x. And we expand all of the bracket and we get the answer is x plus 2x multiplied with ln x. So how we get the x? But we get the x by the x squared multiplied with 1 over x. So the multiplication we get x squared over x. So we simplify the x squared over x is x. And this is the answer for this question.